Hi, this is Jordan from Nuon, and today I'm going to walk you through creating a BYOC app using AWS Lambda and other serverless resources. I'm going to walk you through the whole process from beginning to end, show you what it looks like both for the developer and the customer, and along the way I'll talk a little bit about some of the unique pros and cons of using serverless when building a BYOC app. So let's get this show on the road. So the first part of this demo, configuring the app. Let me show you what we'll be building today. So I have an install I set up ahead of time here for the fictional company Acme Inc. And if I open this up, you'll see that we have 5 components. This is an ACM certificate, so we can handle HTTPS traffic. This is a Docker image containing the actual service itself that we'll be running today. This is a DynamoDB table where we'll be storing widgets, which are nonsense objects that just have an ID that I've created for demo purposes. And then a Lambda function, which runs our Docker image. And then finally, the API gateway, which pulls this all together and creates the REST API that you can use to interact with our service. And going over here to Amazon, I can walk you through the infrastructure really quickly. Oh, before I move on, I should note, we are using our AWS ECS sandbox for this. Even though we're not building an ECS service, I'll explain that as I go. Just be aware, our ECS sandbox can be used for all types of architectures, not just ECS. So going to Amazon, you can see our ECS sandbox has provisioned a VPC for us, as well as an ECS cluster. We're not really going to be looking at those too much. Just be aware that it's there. We need this here just to run our install runner. Because this is a Fargate cluster, it's not provisioning a whole bunch of extra compute nodes you're not going to use. We just want the runner here because it's what's maintaining the install for us, spinning up the gateway and creating the Lambda functions and syncing our Docker images and all that stuff. We also have a Route 53 zone. So part of the install, as part of the sandbox, is this zone that we create for you. And in this zone, we're creating this URL. And this is where we'll be hosting our API gateway. Here we have our Lambda function handling widgets. And I believe you can see it logging in CloudWatch. Just go over here. Yeah, here it is. Can I search all log streams? There we go. So here it is logging. Nothing super interesting happening right now, but it is running. And then finally, we have the gateway itself. And an important thing to note, aside from the routes that I'm creating, so I have a post and a get, so I can create widgets and I can read widgets. You can also see where I've associated with that custom domain name that I've created in our Route 53 zone. And so that's kind of our architecture from top to bottom. Super simple application, but I think it demonstrates kind of all the core pieces of a typical serverless application architecture. So let me show you what this looks like in the terminal. So here I'm going to create a widget using curl. So I'm posting that to that API gateway I showed you earlier. And that's going to create a widget with an ID of 6. And then I should be able to read that from our DynamoDB table. There you go. So that's our application. So let me show you how I built all this using Nuon. So step 1, of course, we got to install the CLI. I'm doing this via Homebrew. If you don't want to use Homebrew or can't use Homebrew because you're not on Mac OS, we do also have an install scripts. I have 4 outdated formula that I need to update. Thank you, Homebrew. But we do have an install script, and you can also just download the binaries from our doc site. So now that I've got the CLI, I'm going to log in and confirm that. Of course, I already have an account because I work here, but if you don't, one will be created for you when you do this. And now that I'm authenticated, I'm going to select our demo org that we use for demos like this. Of course, if you don't have an org already, you can run Nuon orgs create instead and create a brand new org. And now I'm going to create my app. So this is going to do 2 things. It's going to create the application in our platform. It's also going to create a config file locally. You can see that right there. And this config file is what we're going to use to configure our app and our components. Now, all this sort of example config is just here to show you all the things you can do in the config file, but I'm not using any of that today. Instead, I'm going to go over here to the written version of this guide, and I'm going to copy some of our component code. So I'm going to skip right down here to our installer. So this is me telling Nuon that I want to create an installer page to make it easy for my customers to install my app without having to like write any code themselves or do anything super technical. My AWS Lambda app, is that already? Yeah. So this right here is the slug that the installer will be hosted at. I just want to make sure that that's unique. So I'm matching that to the name of my application. And then I'm adding a sandbox. So as I mentioned earlier, we're using our ECS sandbox, even though this is not an ECS app. And that's because the ECS sandbox doesn't provision any extra resources you won't be using if you're not using ECS. Of course, you can create ECS services. We have a demo for that as well. But in this case, we're going to be using it to create some serverless components. So I'm going to stop here, and I'm going to sync our config file. So it's going to take a few seconds, but what this command is going to do is read that config file, and it's going to create the installer, and it's going to configure the application to use that sandbox and that runner. It's going to take a little bit, and when it's done, we'll be ready to add some components. So there we go. So now I'm going to select my brand new app. This is just a convenience. Our CLI allows you to select certain things like apps or installs so that subsequent commands will be run in the context of that app or install. And this just makes it easier. You don't have to like re-enter the name of the app every time. So going back to our config file, let's skip over here and I'm going to start adding all this component config. So here's our Docker image. And what this does is bundle a very simple Golang service, which just has two handlers, one for creating widgets and one for reading widgets. And then I'm going to add our Lambda function. And this is just going to run that Docker image that we added here. Something to note, since this is serverless, there's a couple different ways you can approach this. In fact, when I started working on this demo, I tried it a few different ways. One is to create a separate handler, right? A separate Lambda function for every single API endpoint handler you have. Another is to kind of bundle handlers together into services, which you then like pass, different parameters to. What's best is kind of up to you. You can do either. Nuon supports both. Honestly, you could even bundle all of your Terraform into one giant component. Not sure I would recommend that, but it is possible. If you already have a serverless application in a single Terraform project, you could easily just take that, drop it into a component, and start deploying. But breaking it up into logical pieces does make certain things easier. As you'll see, we do get different like deploy histories per component. So you do want to kind of organize things in a way that's going to make your job easier as the developer of a BYOC app. So moving right along, we're going to add our DynamoDB table, which our function needs. I'm actually adding this here above the Lambda function because when you create this config file, we're going to automatically look at the ordering of the components here and create dependencies based on that. So if you have a component that requires another component to be provisioned and ready before it can be provisioned, you can you make sure that you order them in that correct way. That way you'll be able to, you'll ensure that every time we deploy, components are created in the correct order. All right, and then I'm going to add our ACM certificate. You'll notice I'm putting this down here because our Lambda function, our service doesn't really care about the ACM certificate. It's just the gateway that does. So I'm putting this here first, and then I'm going to go and add our gateway after that. So if you go through this, you'll see that we have our Docker image, our DynamoDB table, our Lambda function, our ACM certificate, and our API gateway. So that's our entire serverless stack right there. And we're using some interpolation variables to create references between these. So you'll see up here, if I go to my Docker image, let's type that, there we go. So this is what's going to sync my Golang build to the ECR registry in the install. And then down here, I'm referencing that image so that my function will use it when it executes. Right? And we're doing similar things here down as well. So here we have the certificate, and then I'm referencing that certificate from the API gateway. So basically, I'm making sure that certificate is created. It's going to be automatically validated via DNS, and then it's passed to our gateway so that it's able to handle HTTPS traffic. So that's all of our components. So now is a good time to stop and sync our config. We have a lot of components here, so it might take a minute. What this is going to do, again, it's going to read that config file, and then it's going to talk to our API, and it's going to create all 5 of those components. It's also going to create an initial build for each component. And that's important because we want those builds ready to go when you create an install. And you'll see what that looks like in a minute. So now we have all of our components ready. And I can validate that with the CLI. I can see we have all of our components, and we should have some builds. Now, some of these you'll notice are still building. That's okay. We don't have to stop and wait for those. The Nuon platform handles asynchronous dependencies between things for you in the background. So even if these aren't ready when we create an install, what will happen is that the install provisioning is queued, and it will wait for those builds to be ready before trying to deploy those components to itself. So now we're going to switch over to the customer experience, and we're going to see what it looks like to install the app. So I'm going to go to that installer we created earlier. There we are. And scrolling down, you'll see that we have 3 ways to create the component, to create the install. But the way I'm going to use now is CloudFormation. It's the easiest, and it requires 0 coding at all. So I'm going to go over here. I'm going to click Create IAM role. It's going to take us to a CloudFormation Quick Create flow. This is just a standard feature that Amazon provides from CloudFormation. And what this is going to do, so I'm going to copy this before I move on. I'll explain that in a moment. So what this is going to do is create the IAM role and all the permissions that Nuon needs to create the install in the customer's AWS account. So if I'm the customer, I've logged in my AWS account. You can see that I'm in US West 2. And before I hit go on this, I'm actually going to update this right here. Now I'm doing this because this is a demo account where we have a whole bunch of installs running. And I want to make sure that I'm not creating a bunch of roles with the same name. Your customer doesn't have to do this, although they certainly can. So if they have an AWS account with a bunch of stuff in it, they're free to rename these as they will. It doesn't affect you as the developer in any way. So now that I've got that, I'm going to create this stack. And that's going to take just a few seconds. If I go to resources, I should see my IAM role. And then clicking on this here, I want the ARN. I'm going to go back over here. I'm going to paste that right there. And I'm going to name my company Jordan's Cool Startup. Doesn't really matter what this is named, basically just a label. And then I'm also going to select US West 2 because that's where I want to put my install. And then I hit install. And that's it. So as a customer, I'm basically done. The Nuon platform is going to handle provisioning the install, as well as creating the initial deploys of all the components. So I can just go get a cup of coffee or something and come back, and it should be done, and the app should be up and running, and I should be able to start creating widgets. And then switching back to the developer experience. Now that the customer has created the install, how does the developer monitor this process? So I'm going to go back over here, and you'll see, yep, already. So this dashboard updates in real time, and you'll see that I have a new install that's provisioning. And I should see some sandbox history. And then if I go over here, components, you'll see that these are not yet deployed. But once this is complete, you'll see some deploys created in this list here for each of those components. And when this is done, you'll have a brand new install. Everything will be green, and you'll be able to monitor the status of it going forward. So yeah, that's pretty much it. I hope that helped explain some of the details of using AWS Lambda with Nuon. There's obviously a lot of flexibility there, especially with serverless and Terraform and the way you bundle things. But this is a good, just a starting point. And yeah, thank you for your time.